In this video, we're going to talk about a zero exponent and what it means. Remember the division rule that allows us to subtract the smaller exponent from the larger? This still works, but what happens if the exponents in the numerator and denominator are the same or equal? That's the case in this fraction where we have 3 squared over 3 squared. Because we have an equal exponent and the bases match, we would take 3 to the second and subtract the denominator. But that would give us 3 to the 0. 3 to the 0 is maybe not obvious. So let's talk about how we could get there in another way. 3 squared is the same as 3 times 3. So we have 3 times 3 over 3 times 3. But what happens if we reduce those out? That's just 1 and 1 multiplied together, and that equals 1. Whenever you have a base raised to the 0 power, it becomes equal to 1, the integer 1, not the exponent 1. 1. So let's take a look at example 1 and see how this might work in an actual exercise. 5 to the 0 is 1. 1 times anything is that thing, so we would have 2 to the third times 2 to the second times 3 to the third all over 2 to the fifth times 3 to the fourth times 5 to the third. Notice that I didn't even bother to write 1. I could have, but it doesn't change anything. So I'm going to erase that again. From here, we need to look at any of our bases in the numerator or denominator to check to see if they combine. Since these both have a base of 2 in the numerator, I can combine 2 to the third times 2 to the second and get 2 to the fifth times 3 to the third in the numerator all over 2 to the fifth times 3 to the fourth times 5 to the third in the denominator. Notice that I have a 2 to the fifth over 2 to the fifth. Since these are just 2 multiplied to itself 5 times in the numerator and denominator, they are equal to 2 to the 0 or just 1, and so they reduce out. 3 to the third and 3 to the fourth have a differing exponent, so I'll subtract 3 from 4 in the exponents. 5 doesn't have any base in the numerator, so I'm done. I'm going to just rewrite this. 1 over 3 to the 4 minus 3, because I took this 3 to the third down, reduced it, and 5 to the third. Remember, since these reduce and this one reduces, I'm left with just 1 over 3 to the first times 5 to the third. In example 2, we have 3 to the third times 7 to the second over 7 to the second times 3 to the fifth times 6 to the 0. Without doing anything fancy, I already know this one is 1, the 6 to the 0. Now I'll look at the rest of these. 3 to the third over 3 to the fifth, 7 to the second over 7 to the second. I'm going to bring this 3 exponent and subtract it from the 5. And because 7 squared over 7 squared just reduces out, this is equal to 1. So what's left in the numerator is 1, and 3 to the 5 minus 3 is what's left. So 1 over 3 to the second. And that's all.